Good day, grade 10s. In this lesson, we're learning about resistance. So if we think about it, lesson 1, we learned about a power supply. Lesson 2, we learned about how the current flows. And now we're talking about things that can cause problem or things that we use, and this is resistance. So resistance slows down the flow of charge. Resistors officially oppose the flow of charge. So anything that opposes the flow of charge is called a resistor. The symbol is a little r, and the unit of resistance is the ohm, and that little funny thing over here is the omega, which is the symbol for the ohm. It is defined as a volt per ampere. So how does resistance come about? So if you look at this little picture, we know that metals are made up of nuclei with a sea of delocalized electrons. But now as the electrons are moving through the conductor, they collide with the particles in the conductor. When they collide, they transfer kinetic energy, and the electrons therefore slow down. So that is what happens with resistance. The kinetic energy is transferred into heat, and if you've ever used a piece of electric equipment for a while, you'll notice that it actually gets a bit warm, whether it's your computer or your radio, it gets a bit warm, and that is your resistance. Now there are a couple of factors that affect resistance. The first is the length. Okay. And the way this works is this. The longer the resistor, where is this thing? The longer the resistor, okay, obviously the more the electrons are going to be bumping into things, so the higher the resistance. The longer, the higher. Okay. The thickness. Now this is an interesting one because you need to think about it this way. The thinner the wire, the more difficult it is to get the electrons through. So the thinner the wire, or the thinner the resistor, the greater the resistance. The greater the resistance as well. So if we've got a nice fat wire, then it's going to allow the electrons to flow through very easily. Temperature. Now this is an interesting one. Temperature, the greater the temperature, okay, the greater the resistance. And the reason for this is because if you increase your temperature, you're increasing the amount that the particles are moving around within the metal. So what happens is, if you look at this little picture again, these little particles are all moving around a lot more, and because they're moving around, they can bump into the electrons much more, and therefore it is going to cause a greater resistance. And finally, type. Certain metals just have, and certain objects have, a greater resistance to electricity than others. So that is nothing we can do about. We can just choose a type. So for example, copper has a very low resistance, and tungsten wire has such a high resistance. It's got a very high resistance. And it's got, if you look at those normal light bulbs, not the energy saving light bulbs, but the normal little light bulbs that have got, you know, it's got the coil and it's got this, and it's getting those little wires. These little wires here are actually made from tungsten, because when the electricity flows through them, they actually got such a high resistance that they get hot, and they get so hot that they actually give off white light. So that is tungsten, whereas copper is what we use to transfer most of our electricity, because it's got such a low resistance. So the factors that affect resistance, you need to know them, you need to understand them, you need to be able to explain them. It's length. The longer the resistor, the more the opportunity can bounce into the other particles, so the greater the resistance. The thickness is actually the thinner. The thinner the resistor, the greater the resistance. Think about this as traffic. If you've got a single lane of traffic, it is very difficult to get a whole bunch of cars through. But if you've got 4 lanes of traffic, it's very easy for all the cars to get through. Temperature, the greater the temperature, the faster the particles are moving, the greater the resistance. And type, certain metals just have an easier way for the little electrons to get through.